Hello everyone, let's try to solve this particular question. In my previous video, I have asked you to solve this particular question, right? I have also given you hint what exactly this reaction and all. Okay, so first step is protonation. Let me draw it here again. So here there are two methyl groups. Here one methyl group is there and here it is OH, right? So in the presence of acid, here this one is acid catalyzed dehydration. So here they have given alcohol and here in the presence of acid, this first step is protonation. This oxygen will get, it will get abstract this hydrogen and it will form OH2 positive. Here it will form OH2 positive and here we have one methyl group, and in the next step it will leave as a leaving group, as we know that water is a good leaving group, right? So and then it will form a carbocation over here on this carbon. As it is leaving with these two electrons, it will get a carbon will get a positive charge. Here it will get a positive charge and here we have two methyl group, here one methyl group. And next step is that somewhat tricky, because see, here there is a nitrogen, right? And here we have two methyl groups. Here we have one methyl group and one hydrogen. So before that you need to know this is the secondary carbocation, right? And if you shift this like one of the groups over here, then you will get a tertiary carbocation. As we know that tertiary carbocation is more stable than secondary carbocation, right? Because of hypoconjugation and inductive effect. So here which methyl which shift you will do, methyl shift or hydride shift, that you need to know. Let's say for example we have did this methyl shift, okay? CH3 methyl shift, you can just write like this, okay? Here if we do the methyl shift, here we have one methyl, and as we shifted this old methyl, here we'll get a positive charge on this carbon, and here we'll get a one methyl group, and here we have already one methyl group, okay? Then what happens? Dehydration. Like here they have mentioned heat, it is an elimination reaction generally. So here we'll get a more substituted alkene, okay? So you can see here there is a hydrogen, right? So this hydrogen will leave and here we'll get a this more substituted alkene as a major product. And in case if you do this hydride shift over here, let me draw that product also, right? This is a more substituted alkene. According to Setzer rule, we'll get this as a major product rather than this. And here we can get even different products. You can remove hydrogen from here also, but it is not a more substituted alkene. So that's why this will be the major product. If you have any doubts, let me know in the comment section. Okay, so yeah, that's it for this particular video. Just take care of yourself and be kind. Bye.